Greetings and welcome back. In this video, we are going to create a beam emitter effect. It'll be kind of like a bolt of lightning. We're going to make it arc around a little bit and do some fun stuff. It'll be pink probably because that's cool. So let's start off as we have before. Let's make a new folder, which we will call beam. Step inside of it, and the first thing we need is a material. And we'll call this mat_beam. Now, a thing about this, what we need out of this material is a horizontal beam-looking texture. So I'll show you how to make one of those procedurally. Let's jump into the material editor. And since this is going to be like a lightning effect, of course you could create a laser effect the same way. You'll probably see how before we're done. Let's go ahead and make this translucent. We'll make it unlit. Then I'm going to show you how to make a horizontal beam effect for a texture. Let's right click and we're going to create a texture coordinate. If it'd help if I could spell coordinate, that would be great if I could do that. So if you take a look at a texture coordinate, it is really just a green and a red gradient that are working against one another perpendicularly. If we grab a component mask and we filter out red, so we're only looking at green, we have a vertical gradient. Now, that is a steadily incrementing or increasing value. So if I take the sine of a steadily incrementing value, I get something that looks a bit like this. So it's starting off underneath 0 and then it's curving back up over because a sine wave kind of does this up and down sort of motion, which maybe you can see my mouse actually doing that. If not, I could draw you one, but we'll skip it. What we'll do though is before we actually plug that into sine, let's multiply it by 0.5. And we'll plug that in. And there we go. You can see that now it's going from dark to light to dark. Now I'd like a little more contrast in that, make it a little more apparent what we're looking at. So let's do a power like so. And we'll take the power, we'll increase it to 3. So we're kind of, I guess, cubing the result. And then there's what we get. So it's obviously very dark at the top and bottom, and it's a horizontal looking beam. That's exactly what we want. So that's perfect. That's awesome. Let's now take that and we'll bring in a particle color and a couple of multiply nodes. We will multiply the color by this result, and that will give us the emissive color. We will multiply the alpha by this result, and that will give us the opacity, and then we are done and we are happy. So we'll click apply, we'll click save, and then we will take a break to have a beverage. No, we won't do either of those things. We will instead create our particle system, because that's more important right now. Let's right click and create a new particle system, which I'll call P_beam, like so. We'll double click and open it up. The very first thing I'm going to do is right click on this empty spot and add a type data for beam. Now, this is going to immediately look like it's broken, and it kind of is, but we're going to unbreak it. Let's take the required module and we will drag our new matte beam material in there, because that's important. Now, a couple of things. A beam requires, well, depending on its type, right? So under beam data, the beam method could just be set to distance, in which case we can just apply a distance and this should probably just work. But we're going to leave it set to target, which means we need to supply a source and a target for this thing. So let's right click and go under beam, and we will add a source. Right click again, go under beam, and we will add a target. Now, that's going to look like it kind of fixes it and then breaks it again. That's because source and target have the same default values, which is not particularly useful to us. So let's take x and we'll set it to -200. By the way, this is in the source module, the source property. It has a constant value, so we're going to take x in this and set it to -200, take y and z and set them both to 0. Target, we're going to do the opposite. So we will go to 200 on the positive side. It's going from -200 to +200. And the only catch now is that our beam, if we take a look, there we go. So it's still kind of doing this weird sort of stretchy thing, which is not super useful for us. We're going to take its speed and set it to 0. So 0 indicates an instantaneous beam, so it's like a beam of light. Now let's move Cascade out of the way for just a minute. Let's bring our emitter in here, and there we go. There is our beam being spawned. Now currently it has a lifetime of 1 second, which is pretty much expected. We're spawning 20 of those. We don't really need that many. We could set that down quite a bit lower. So you see there's just 1 beam pumping out every second. That's fine. We'll tweak that out a little bit later. Let's leave it down at 1 for now. Now initial size is a bit of a concern. 25 is a little high, so let's pull this down to something like 3s down the board. So now it's just this tiny little laser beam. I don't want to change the color of this over the life of the particle, so I'm going to take my color over life module and delete it. In its place, I'm going to add an initial color module, which I'll put pretty high up on the stack. And we will give this a color of, let's do something pink. So I think it's like, what, 20 by 1 by, I don't know, 10? That looks pretty pink to me. Okay, so now we get to talk a little bit about tangents. Now, it's possible, yeah, so here is just kind of an example of what we've got right now. So we've got our emitter located here, so it's like a little star thingy, and then we've specified a source location and a target location. What we're going to do now is add some curvature. We're going to make this thing curve up into the air, and that requires a couple of things. We need tangents. So our source can have a tangent location. And our target can also have a tangent location. And what these are, when I say location, I mean this is a location in 3D space that represents a spline's tangent handle if it were to have one. So if this was like a Bezier curve and you took the tangent handle for this point and you dragged it up into the air and did the same thing over on this side, you would expect your curve to do something at least a bit like this, but only a lot smoother than I can draw by hand. There's a catch to this. There's a problem here, and that is that we need to give this spline more points to interpolate. Right now it has no interpolation points, meaning it's a spline that just has a point at the beginning and a point at the end, and therefore it can't bend and it can't curve. We can add interpolation points like 1, 2, 3, 4, 5, and then those points will be used to add curvature. So let's focus on getting that in place. We'll make this little spline bend up into the air. So let's jump back over to Unreal. Now, I'm going to add my interpolation points first, because if I don't, this is going to be a really boring example. Let's take our interpolation points here. Now this is in the beam data module, and we'll set that to something like 5 for now. Now for source, if we take a look down at all the source properties, scroll down, you're going to see the source tangent. Change the source tangent method to user set. And then we're going to change its value, which is a constant of 100 for x. We're going to zero that out. We're going to take z and set that to 100. And he curves way up into the air. That's maybe a little much. Let's try 10 for starters, and then we'll just increase it from there. We'll probably have to make it a bit higher. Now for target, we'll do the same thing. We're going to take the target method and set it to user set, zero out x, and we'll move this negatively, because that's what you do. And now it's curving up into the air, but it's not super pretty yet. There's a couple of things we can do. Let's go to beam data first off, and we can take the number of sheets to render. We can increase that. So that'll help a little bit. So it's starting to be a little more apparent what we're looking at. We could take the interpolation points, which we don't want to go too crazy overboard with this, but we can set it up to like 20, and now you can see it's starting to get really curvy and looking pretty good. Let's increase those tangent locations. Let's do 40 by -40 on the target. There we go. Now it's starting to arc up into the air pretty well. I'm liking it. So now let's actually make this move around a bit like lightning. To do that, we're going to add a noise module. I wanted to say modifier, but it's a module. So let's go back over to beam, and we'll add a noise like so. Now, to make this happen, we need to specify a frequency. Now, there's a lot of things you can control in the noise. I'm not going to go over each and every setting. We're just going to get this working, and then if you want to play with the different settings to make stuff happen, please feel free. We'll take frequency and we'll kick it to, I don't know, let's try 10 for starters. We'll also set low frequency enabled, so that gives us a low value. Then we need to specify the noise range, which that currently just set to a constant, and then we've got our noise speed as well. So let's see here. We don't really care too much. In fact, let's do this. Let's take our noise range and let's set it to a uniform. And we're going to take our max and set that only in Y and Z. We're not going to set that in X. Let's say in Y to about 10 and in Z to about 10. And you see it's already starting to tremble and flicker a little bit. And then in X, we'll set it to negative, or I'm sorry, in minimum, we'll say Y is -10 and Z is -10 as well. And now it's flickering quite a bit more. Let's drive that a bit higher. Let's do 30 and -30. There we go. Now it's starting to kind of jitter and get all over the place, which is pretty much what I was hoping for. And we can take our initial size and let's kick that up. Let's do maybe 6. There we are. And over in our beam data, we can take, let's see, we've got our beam set up here. There's our overall number of sheets. Max beam count is currently at 1. Let's set that to maybe 3, and then we'll spawn some more here. Let's say, there we go. So now we've got a whole lot more beams, and we've got some pink lightning. We could take that and drag it down to the ground, and now it's arcing between 2 locations. Of course, we could put static meshes under that if we wanted to. If we wanted, for some reason, to update the source and the target locations, you have some options to do that. One is that you could take the source method and you could set it to an actor, and all you have to do is specify that actor, and then the source would follow that location. You can also use user set, and then you could start talking to that location by way of a parameter. So if you set it to user set and then take your source and set it to a particle parameter, you could then talk to that inside of Blueprint. There's actually an example of that in the intro to C++ videos that Epic released earlier. That was the project where we created a game with a character that runs around and picks up batteries that fall from the sky. When you hit the E key and attract a battery, it discharges an electrical arc into the character. And we actually used what I'm talking about. We used a particle parameter to have the arc of lightning follow the character around at about 10 to 15 frames a second. So you could totally check that out, but for now I'm going to keep this very simple. We have officially created our beam emitter. So you've seen how to add a beam type data, how to set up a source and set up a target, how to apply some noise to make it look like lightning. So that is going to wrap things up for this video. Thanks a lot.